everybody had a good time at dinner time.
Yes.
And now we'll have a couple of presentations before the sun goes down. So to start off, we're going to have Arushi and Artash talking about their model of the Trappist-1 exoplanetary system. So take it away.
Hi everyone.
Hi.
Good evening, my name's Artash.
And my name's Arushi.
Bonjour, je m'appelle Artash.
Bonjour, je m'appelle Arushi.
We are a maker family. We've been making projects for the last 5 years. Also, a couple years ago, we joined the Royal Astronomical Society of Canada, and we've learned a lot of stuff. And we've also made many projects for the last 5 years. And I'd like to share with you one of our latest projects about the Trappist-1 planetary system. So the Trappist is an exoplanetary system 39 light years away from our star, or our Earth. And it has 7 planets orbiting around its main star, an ultra-cool dwarf star. Trappist stands for transiting, T-R-A, planet is something, and a small telescope. And the reason they called it Trappist and they fit the TRA at the beginning is because they named it after a Belgian beer, because it was discovered in Belgium by Michael Guillan. So it has 7 planets, just 1 less than our solar system, which has 8. And one of a big difference is that the whole Trappist-1 exoplanetary system could fit inside the orbit of Mercury. So it's real compact. So if there's so many planets in such a small distance, how come all the planets hasn't crashed into each other or something unstable happened? Well, the answer to this is that all of these planets, they kind of form a resonance chain. So basically, simply, it means that all of these planets orbit their parent star in harmonic motion. So each of the orbits have whole number ratios to compare with. And so this is a chart showing all the ratios of the planet's orbits. So for every 2, the first planet, the innermost planet does, next one does 3, 4 continuous, the inner one does 24, and the second inner one does 15, 9, 6, so on until 2. So the reason this helps the planetary system stay stable is that while they're doing this kind of orbit around their parent star, they're all tugging at each other gravitationally, so that none of the planets are ever found in the same place at the same time, ever. And it's a pretty old solar system. In most simulations, these kind of systems crash within a couple million years. But Trappist has been going for many billion years so far. So and a funny thing is, if you speed up the orbits of all these planets, you can actually associate each of them with a note. It's like a frequency of the orbit around the star with a note. And using those notes, you can actually create music that we'll demonstrate to you later in our presentation. So we wanted to make a model of the Trappist-1 planetary system and show all of the harmonic motion orbits using these lights by blinking them. So we first started with a big board, and then we decided to represent each orbit using a light strip, these light strips, and we put all of them around the star, a light globe. And we even found the distance between the planets in the Trappist-1 planetary system, and we organized all the light strips in like the same pattern. So the first two are very close to each other, so on, and then the last ones are really far away from each other. So after we put all these light strips, we also had to wire all the light strips to a bunch of relays to connect to an Arduino, a microcontroller that we use a lot for our projects. And then we had to program all of the lights to flash according to the Trappist-1 planetary system's orbits. So for that we used a system called Reaper. So using Reaper, we connected Reaper to the Arduino, and then we used that to flash the lights in the correct order. And now we're going to give you a demonstration. So we're going to show you all the planets' orbits, while at the same time you can listen to the music that's generated by the system. One, two.
Sorry for that.
Well, we presented this project at lots of places. For example, at a RASC place in Toronto, and at a Toronto Science Rendezvous, at a yeah.
Yeah, at the Ontario Science Centre, and we also got invited this year to speak at the Science March. So we were very honored actually. They asked us to speak about one organization, and we actually spoke about the RASC and how it has helped us in our journey of space exploration and astronomy. So as a Baker family, we are really thankful, for whatever opportunities the RASC has provided. And I think it's splendid that we need to get interest in science and space coming at all levels, because we feel like conversations about science, technology, space, astronomy have to start at the family level first. Then we can expect, it should be as normal as speaking in bus stops. We always talk about weather, but we end up talking about, let's talk about the solar flares or astronomy or any subject under the sun or anything. And I think that's the kind of change we want to bring. So because space is intergenerational, so we have to keep the thing going from one generation to the other. So thank you once again for this time and the opportunity.
Okay, we have time for one or two questions if anybody has a question.
Oh, in the back.
One in the back, Bill.
We need a mic.
Bill.
Ooh, wonderful presentation, thank you. I was curious about your light strips and how quickly the LEDs went around. Are they indicative of the speed of the orbit of the planets around Trappist in some sort of ratio to real time?
Well, as I said before, each of these lights represent a different orbit of a planet with these ratios. So we exactly copied these ratios inside these lights. So each time the innermost light will blink 24 times, the outer one will blink 2 times, and so on with all the ratios. Yeah, and we've also converted them into the notes, piano notes, because when we speed them up enough, we get a type of frequency which we can associate with a note to play the music. To get this music, we collaborated with University of Toronto, with an astrophysicist, and who helped us get this music.
So I think everyone here is really familiar with STEM, but maybe not so much with STEAM, where you add art to the science. And I love the way that you've used sound and light together. And so I'm curious to know if you have any future aspirations to collaborate with artists as well.
Well, we really like displaying things visually. Like we always like making projects instead of just like making like an app or something. So we haven't actually ever collaborated with an artist before, but we have made.
Actually, we did participate in the science art festival and the science rendezvous, where we put on the projects at the street level for people to just pass by and watch it. And that was the part of the science art, basically, festival. Yeah. So, I mean, if there are more opportunities, we'll be happy to share the project. And we were part of the Maker Festival for the last 4 years, where we have been displaying about 25 projects which we have made so far.
I think that's brilliant. I would encourage you. So thank you.
Thank you so much.
Thank you very much for the presentation.